Let's now take a look at some more complicated work problems. Example 3. Carlos can renovate a kitchen 4 times faster than Peter. When they work together, the renovation takes 8 days. How long would it take each of them individually to renovate the kitchen? Alright, so we have a work problem, and the first thing that we should do is recall our work formula that we can use to help us solve this type of problem. The work formula states 1 over A plus 1 over B equals 1 over T, where A is the amount of time that Carlos would need to renovate the kitchen by himself. B is the amount of time that Peter would need to renovate the kitchen. And T is the total time that the two together would need to renovate the kitchen. So let's identify these variables off to the side. A is the amount of time that it would take Carlos to renovate the kitchen. So let's say amount of time for Carlos. And B is the amount of time it would take for Peter to renovate the kitchen by himself. So we have amount of time for Peter. T is the total time that it would take if the two worked together. So total time working together. So those are our variables. Now let's go back to the problem and fill in exactly what each of these are equal to. A represents the amount of time that it takes for Carlos to renovate the kitchen. Well, the first sentence in our problem says Carlos can renovate a kitchen 4 times faster than Peter. But it doesn't tell us how much either Carlos or Peter takes to renovate that kitchen. So both of these quantities here are going to be unknown quantities or quantities involving a variable. So let's go back and let's see what is the amount of time it would take for Carlos to renovate the kitchen. Well, our problem tells us that Carlos can renovate a kitchen 4 times faster than Peter. What does that mean? That means that however long Peter takes, Carlos is going to be 4 times faster. Or opposite, whatever amount of time that Carlos takes, Peter will be 4 times slower, right? Take him 4 times as long. So let's just suppose that it took Carlos 12 days. Let's just say it took Carlos 12 days to renovate this kitchen. Well, he works 4 times faster than Peter. Peter works 4 times as long. So 4 times 12 is actually 48 days that it would take for Peter. Now this is just a suppose, right? But the idea is whatever the amount of time that Carlos takes, it will take Peter 4 times as long. Since we don't know the actual amount of time, we're going to let X represent the number of days that it takes Carlos to renovate the kitchen. And Peter, who works 4 times slower, will take 4 times X days to renovate the kitchen. Does that make sense? And the total time they work together, well, that's given to us. When they work together, the renovation takes 8 days. So together, they take 8 days to renovate the kitchen. We now take these 3 expressions and plug them into our work formula. And that gives us the following equation. 1 over x plus 1 over 4x equals 1 over 8. And this is the rational equation that we want to solve. Luckily, it's a pretty simple equation, right? Our LCD is simply the least common denominator for 8, 4x, and x. And we really don't have to do much work at all to notice that our LCD is 8x, right? The smallest denominator that 8, 4x, and x would all divide into. So, taking our rational equation, we want to multiply each term in our equation by the LCD. And why do we do that? We do that so then we can cancel our denominators, right? So we take our equation 1 over x plus 1 over 4x equals 1 over 8, and we multiply each term by our LCD, which is 8x. So 8x times each term in the equation. And then we use that to cancel our denominators. So x would cancel with the 8x and leave just 8. X would cancel with the x. 4 would cancel with the 8, leaving us just 2. And the 8 would cancel with the 8, leaving us 1. Pulling everything together, that tells us we have 8 times 1, or just 8, plus 2 times 1, which is 2, equals x times 1, which is just x, or simply that 10 equals x. What do you know? In other words, let's take this and go back. The amount of time for Carlos to renovate the kitchen would be x days, or 10 days, according to our result. And the amount of time for Peter would be 4 times x, or 4 times 10, which would be 40 days. That solves our problem. This brings us to our last work example. Example 4. Jake can cut and split a cord of firewood in 6 fewer hours than Skylar can. When they work together, it takes them 4 hours. How long would it take each of them to do the job alone? All right, we should be getting really good at these work problems by now. First, we want to pull up our work formula. Our work formula states that 1 over a plus 1 over b equals 1 over t. Next, we want to identify our variables a, b, and t as they relate to the problem. A is going to represent the amount of time that it takes Jake to split the cord of firewood. So let's say A is Jake's time. B represents the amount of time it takes Skylar to split that same cord of firewood. So let's call B Skylar's time. And T is the time it would take them if they worked together to split that cord of firewood. So let's fill in our expressions. It doesn't tell us the exact time that either Jake or Skylar can cut that cord of firewood. But we do see that they're related to each other. So let's let one of them be the variable x, the unknown time x. Jake can cut and split a cord of firewood in 6 fewer hours than Skylar. So I'm going to let x, hours, because that's our time, be the amount of time it takes for Skylar to cut and split that cord. Then Jake can do it in 6 fewer hours. In other words, 6 less hours than it takes Skylar. So that means that Jake would be x minus 6 hours. Make sense? Now working together, it takes them 4 hours, so our time together is 4 hours. And we now have expressions for our variables a, b, and t that we can substitute back into our work formula. Our equation becomes 1 over a, or 1 over x minus 6, plus 1 over b, or 1 over x, equals 1 over t, or 1 over 4. Here is the rational equation that we are going to use to solve this problem. We need the LCD, and the LCD has to include the factors of 4, x, and x minus 6. So our LCD is going to be 4x times the quantity x minus 6. Do you see that? So we're going to take each term in this equation and multiply it by our LCD. So let's rewrite our equation over here. And I'm going to leave lots of space in between each term because that's a rather large LCD. So I have 1 over x minus 6 plus 1 over x equals 1 over 4. And the way we solve rational equations is we multiply each term by our LCD, which is 4x times the quantity x minus 6. And we do that to the first term. We multiply that LCD through to the second term. And then we multiply that LCD through to the term on the right side of the equation. Now, why do we do that? Because strategically this will help us cancel all the denominators and make our equation simpler in form. In the first term, the x minus 6's cancel. In the second term, the x's cancel. And in the third term, the 4's cancel. And so, rewriting our equation, we have 4x times 1, which is just 4x. 4 times x minus 6. And on the right side, x times x minus 6. Perfect. Let's use the distributive property to go through and distribute the 4 through to the quantity here, x minus 6, and the x through to the quantity here, x minus 6. And that's going to give us that we have the equation 4x plus 4x minus 24 equals x squared minus 6x. Now this is a more complicated equation than any work problem we've done thus far. That's because this is a quadratic equation, an equation of degree 2. And do you remember how to solve those? To solve quadratic equations, we bring all terms to one side and set equal to 0. Before doing so, though, I'm going to put the two 4x's together to give me an 8x. Just makes one less step when we're moving things over. So now we're going to bring the terms over, so we're going to subtract 8x from the left side and the right side to bring it over to the right, and we're going to add 24, right? So we put everything together on one side, and what this is going to give us is this is going to give us the following equation. X squared minus 14x plus 24 equals 0, because this goes to 0, correct? Yay, we are almost done. Our last step will be to solve this quadratic equation. We can try and factor it, we could complete the square, or we could use quadratic formula. This polynomial is a simple polynomial and it's factorable, so I'm going to factor this polynomial. We're looking for two numbers that will multiply to 24 but add to negative 14 as we're doing it. And this thing, very quickly, I will write down factors as x minus 2 times x minus 12, right? Because negative 2 times negative 12 gives us plus 24, and the negative 2x and the negative 12x gives us negative 14x. So a couple more steps, we're almost done. Now that we've factored our polynomial, we set each quantity equal to 0, correct? Using the 0 factor property. And so that tells me I have two answers. X is either equal to 2 or x is equal to 12. Now let's go back up here into our problem. So if x equals 2, that would mean that Skylar's time is 2 hours. And Jake's time is 2 minus 6, which is negative 4 hours? That doesn't make any sense. Oh, that's an extraneous solution. X equals 2 isn't going to work to solve this problem for us. But x equals 12, that's another story. If Skylar's time is 12 hours, in other words, it took him 12 hours to cut and split this cord of firewood, then it would take Jake 12 minus 6, or 6 hours. And then that would make sense that working together it would be faster at 4 hours. So our final result is that it would take Skylar 12 hours to do the task, and it would take Jake 6 hours to cut and split that cord of firewood. Wow, that was a big problem. I hope it makes sense. Go step by step as you're approaching work problems. Good luck.